we will be using the idea of the inverse function to come up with the derivatives of the inverse functions of all the functions we have already found the derivatives for. So we'll essentially double our store of differentiation facts by using this idea of inverse function. And in pre-calculus, you've learned to notate the inverse function as f negative 1 of x, whereas f without the negative 1 is considered the function itself. So y is the inverse function of f if and only if x is f of y. Notice the negative 1 here and the lack of the negative 1 here. If the forward function is f, the inverse function is f to the negative 1. And we have a quicker way of writing that, which is y is the inverse function of f if and only if x is the forward function of y. And this is how we understand that. This is what we expect from the inverse function definition. That is, y equals the inverse function of x. Well, if we take x from this side, which is f of y, what this says is that f inverse of x, where x is f of y, and we expect the function and the inverse function to undo each other and simply leave you with y, and we end up with y equals y. So that's the idea of the inverse function. The inverse function is the function that undoes the original function and leaves us with the argument itself. And it works the other way around. Right? We can start with x equals f of y and replace y with what y is according to this definition, which is f inverse of x. And f and f inverse undo one another and leave you just with the argument, and that gives us x equals x. That's essentially what we mean by the inverse function, is that the inverse function undoes the forward function, and the forward function undoes the inverse function. And you end up, what you start out with before you start the operations is what you end up with when you finish taking the inverse of the function, and vice versa. You start with x and you end up with x. The function undoes the inverse function. So here's our thought, and that is that we can possibly use the inverse function to help us come up with the derivatives of the inverse functions for all the functions we already know. We know a bunch of functions already. We know e to the x, a to the x, all the trig functions, and soon we will know the hyperbolic trig functions. But we do not know the derivatives of the inverses of all those as of yet. And the inverse functions of e to the x is ln of x, so we'll find the derivative of ln of x. We'll find the derivative of the general log, because it's the inverse function of a to the x. And then we'll find the derivatives of all the inverse trig functions using the trig function derivatives we already know, and the same thing with the hyperbolic trig functions. So this is a fairly important concept for the half of the derivatives that we don't know already.